Now let's begin our 10 question part. Let's begin with our first question. Here we have f of x is equal to cosine ln of x plus 3. So what is the derivative of f of minus 2? So first, how we take the derivative of cosine function? Let's say it is cosine a. Okay, so the derivative of cosine a is equal to, what is the derivative of cosine? It is minus sine, right? It's minus sine a, and also I need to take the derivative of this a. Okay, so here when we look at our question, here we have ln of x plus 3, right? So this is our a. So I also need to take the derivative of this one. So what was the derivative, what was the formula for natural log? It is, when I take its derivative, it's equal to, let's say this is b, okay, the derivative of b over b, right, which is here equal to the derivative of x, it's 1 over b, it's the whole thing, it's x plus 3. Okay, now let's go back to our question. So the derivative of cosine of natural log of x plus 3. So we know that this is equal to minus the derivative of a, which is equal to this one, and this is equal to 1 over x plus 3, right? So it's minus 1 over x plus 3 times sine natural logarithm of x plus 3. Okay, so what was the question? The derivative of f of minus 2. So let's put minus 2 instead of x here. So here it is equal to minus, this is 1 over, when I put minus 2, it's minus 2 plus 3, it is 1 times sine. So here when I put minus 2, it is minus 2 plus 3, it is 1, so it will be ln 1, okay. So this is equal to, so this is 1 of course, so ln 1 it's equal to 0, right? So sine 0 is equal to 0, so this is 0 times any number is equal to 0. So 0 is our answer for our first question. Let's continue with our second question. Here we have a is the element of positive real numbers. F of x is equal to a over x squared plus a over x cubed to the power of 2. So the derivative of f of 1 is equal to minus 80. So what is the value of a? So let's find its derivative first. So the derivative of f of x is equal to, I will put this 2 in front of the parentheses, so it is 2 times the inside, it will stay as it is, a over x squared plus a over x cubed, right? And also I need to take the derivative of inside of this parenthesis. So how can I take its derivative? Let's do that here. So a over x squared plus a over x cubed, I can also write this as derivative of this. I can also write this as a times x to the power of minus 2 plus a times x to the power of minus 3 and all this derivative. Okay, so here it will be, I will put this minus 2 in front of here, so it is minus 2ax to the power of minus 3, right? It's minus 2 minus 1, it's minus 3. So I will put this minus 3 in front of here, so it is minus 3 a times x to the power of minus 3 minus 1, it's equal to minus 4. Okay, so I can also write this as minus 2a over x to the power of 3 minus 3a over x to the power of 4. Okay, so let's write this here. So it is minus 2a over x to the power of 3 minus 3a over x to the power of 4 Okay, now I know the value of the derivative of f of 1, which is equal to minus 80, right? Let's use this one. So instead of x, I will write 1 here. So the derivative of 1, which is equal to here. So when I put a, it's 2 times, it's a over 1, a over 1, a plus a over 1 is a, and here is also a, so here is 2a, right? 2 times 2a times, when I put 1 here, it is minus 2a minus 3a, so it will be minus 5a, which is equal to minus 80, right? So from here, let's make this positive, and then from here we will have 4a times 5a, it's 20a squared, which is equal to 80. So a squared is equal to 4, so a can be equal to 2, or a can be equal to minus 2. But in the question it says that a is the element of positive real numbers, that's why a cannot be equal to minus 2, so a is equal to 2. On our third question, here we have f of x is equal to dx squared over dx plus dx cubed over dx squared plus dx to the power of 4 over dx to the power of 3. So what is the value of f of 1? So here we know that this is the derivative of x squared respect to x. Okay, so we don't need to change anything here. So when we look at this one in this expression, we need to change this. Let's say x squared is equal to a. Okay, so if x squared is equal to a, which means x cubed is equal to a to the power of 3 over 2. Right? When you take its when you want to find x cubed, you will just multiply this by 2. So how can I rewrite this one now? I can rewrite this as dA to the power of 3 over 2 over dA. Now everything will be much easier. Let's look at this one. We will do the same thing for also this one. Let's say x cubed is equal to b. Okay, so x to the power of 4 will be equal to b to the power of 4 over 3. Okay, so this will become db to the power of 4 over 3 over db. Okay, we just put these values in their places. Now let's rewrite our function. So our f of x is now equal to dx squared over dx plus dA to the power of 3 over 2 divided by dA over dA. Of course, this is derivative. This is not the fraction, the division. And then plus, here we have dB to the power of 4 over 3 over dB. Now we said that a is equal to x squared, right? So the question asks us the value of f of 1. So we will put 1 instead of x. Okay, so the derivative of x squared is equal to 2x, right? So this is equal to 2x. So we said that a is equal to x squared. If we put 1 instead of x here, we will still get 1. So we can use 1 instead of a here. So it will be equal to plus 3 over 2 because we put this in front of the a. And then it's 3 over 2. It's times a to the power of 1 over 2. Why? Because 3 over 2 minus 1, it's equal to 1 over 2. Plus, same thing, we said that b is equal to x cubed. So when I put 1 instead of x, b is equal to 1, right? So I will put this 4 over 3 in front of b. So from here we will get 4 over 3 times b to the power of, it's 1 over 3. 4 over 3 minus 1. Yes, it's 1 over 3. So now let's do this. So this is all equal to 2 times 1, it's 2. Here we have 3 over 2 plus 3 over 2 plus here we have 4 over 3. So let's multiply, let's make these all equal to 6, the denominators. So I will multiply this by 6, this one is by 3, and this one is by 2. So from here we will get 12 plus 9 plus 8 over 6. So this is 17 plus 12, it is 29 over 6. So this is the answer for our third question. Let's continue with this question. So here we have, find the maximum area of the rectangle that it's 1 point on the line y plus 3x minus 12, which is equal to 0. So here we have this rectangle and it's asked the maximum value of the maximum area of this rectangle. Okay, so let's say this is our x point, okay, this is our y point. So our the area of this rectangle is equal to x minus y, right? So here I know that the 1 point of this rectangle is on this line. So which means I can use this equation for our question. Okay, so here when I leave this y alone, okay, when I this y alone, I will get 12 minus 3x, right? So I can use this y here in this formula. So our area formula would become x times 12 minus 3x. Okay, now the area is dependent on the value of x. Now I got rid of y, so the only thing our area is dependent is the value of x here. Okay, so how we can find the maximum area of this rectangle, of this area? So we know that the maximum value it can get is the value that makes its first derivative equal to 0, right? So let's do that. So area is equal to, let's multiply this, it's 12x minus 3x squared, right? So its first derivative is equal to 12 minus 6x. So I will make this equal to 0. Okay, so from here 6x is equal to 12 and x is equal to 2. So this 2 is our critical point. Remember? Now we will draw our table, right? So 2 is our critical point. So I will do like this. So here we have the first derivative of f of x, and here we have our f of x. So as you can see here, it has negative sign x. That's why we should start with minus. Okay, it's minus and plus. Okay, now as you can see here, our function, it is increasing and after that it is decreasing. So when I draw my curve here, as you can see, when x is equal to 2, I have the local maximum value, which is the maximum area of our rectangle. You see, so all I need to do is to take this 2 and we should put this 2 instead of x on our function. So let's do that. What was the formula for area? So it is this one, right? So let's do that. So our maximum area is equal to 12 times 2 minus 2 times 2 squared, it is 4. So it is 24 minus 12, which is equal to 12. So this is the answer for our fourth question. Now let's continue with our fifth question. Here we have the length of the fence is 30 meters. What is the maximum area of this garden? So here we know that these are equal to each other. So let's say this one x, this one also is x. So this length also would be equal to 2x, right? Let's say this is y and this is also equal to y. So the area of this garden would be equal to 2 times x times y, right? So let's get rid of this y. Okay, so how we can get rid of this y? We know that the length of the fence is 30 meters. So fence is, as you can see, it begins from here till here. So the 30 meter is equal to, it's 2x here, it starts from here, so it's x plus y plus 2x. So it's 3x plus y. Okay, so from here we know that y is equal to 30 minus 3x. Okay, so now in this formula I can write this one instead of y. Okay, so let's do that. It's a is equal to 2 times x times 30 minus 3x. So here, let's rewrite this again. So this is all equal to, it is 60x minus 6x squared. Now, I know that the maximum value it can get is the value that makes its first derivative equal to 0, right? So let's do that. Let's take its first derivative. So its first derivative is equal to, it's 60 minus 12x. So let's make this equal to 0. So 12x is equal to 60 and x is equal to 5. So this is our root, this is our critic point. Okay, let's draw our table here. So we have here 5 and let's do like this. So this is the derivative of f of x and here our function. So here, as you can see, where was it? It was here. Yes, its sign is negative, right? So that's why it will start with negative and positive. As you can see here, our function, it is increasing, here it is decreasing, and our curve will be like this. So as you can see here, we have our local maximum value, which gives us the maximum area of this garden, right? But this is not the value, this is x. We will find the value of y. Okay, so when I put this 5 instead of x on in our function, I will be able to find the maximum area of this garden. So let's do that. The maximum area is equal to, it is here, we have 60 times 5 minus 6 times 5 squared, it's 25. So this is all equal to 300 minus it's 6 is 33, it's 150. So this is all equal to 150. Also another way is you can just take this 5. Okay, so you can just take this 5 and we know that y is equal to 30 minus 3x. So instead of x here also you can write 5. So from here you will get y as 30 minus 15, which is equal to 15. Okay, we know that x is equal to 5. So also when you put here, it is 2 times 5, 10 times 15. You will also get 150 also here. You can use both way. You can use whichever is easier for you. So this is the answer. 150 is the answer for our 5th question. Let's continue with this question. Here we have, write an equation for the normal line to the curve f of x, which is equal to x to the power of 3 minus x plus 2 at the point when x is equal to 1. So to find the slope of normal line, it's better for us first to find the slope of tangent line. Okay, so how we find the slope of tangent line? By taking the first derivative of this function. So let's do that. The first derivative of f of x is equal to, it's 3x squared minus 1, right? And then after that I will put this value x here, and then it will be the derivative of f of 1 is equal to, it is 3 minus 1, which is equal to 2. So this value is the slope of our tangent line, which is equal to mt. Okay, so I know that mn, the slope of the normal line, times mt is equal to minus 1. Why? Because they are perpendicular to each other, right? So I know the value of mt, which is equal to 2. So from here, mn is equal to minus 1 over 2. Okay, so now we know the slope. We know one point which is equal to 1 here. Okay, so we can find y from that, and we can write the equation. So let's do that. I know that x is equal to 1. So when x is equal to 1, our y value is equal to, it is 1 cubed minus 1, it is 0, it is 2, right? So when x is equal to 1, y is equal to 2. So what was the slope formula? It is m is equal to y minus y0 over x minus x0. So I know the value of slope, which is equal to minus 1 over 2. So minus 1 over 2 is equal to y minus 2 over x minus 1, right? So from here we will do cross multiplication, and so let's multiply this minus sign with this one. So it will be minus x plus 1 is equal to 2y minus 4. So from here, so it will be 2y. Okay, let's put this x to the other side. It will be plus x. So this y minus plus 1 will become minus 1, and it will be minus 5, which is equal to 0. So this is the equation for the normal line to the curve f of x, x to the power of 3 minus x plus 2. Let's continue with our 7th question. Here we have a and b are the element of real numbers. Limit as x approaches 4, the square root of 2x plus 1 plus a over square root of x minus 2, which is equal to b. So what is the value of a times b? So here, when I put 4 instead of x, as you can see, this value makes our denominator equals to 0, right? When I put here 4, it will be 2, and 2 minus 2, it will give us the value of 0. So I know that when I divide this numerator by this 1, I will get some real numbers. Okay, so if this is just a number, okay, so when you divide number by 0, okay, if this numerator is a number and when you divide this by 0, the solution will be undefined. Since here b is a real number, the numerator also should be equal to 0 in order to get real number by using L'Hopital rule. Okay, this numerator also should be equal to 0. Why? Because from 0 over 0 we can use L'Hopital rule, and after that we will be able to find the value of b here as a real number. Okay, so that's why we will now make this equal to 0. So let's do that. When I put 4 instead of x here, I will get square root of 2 times 4, it is 8, plus 1, it is 9, plus a, which is equal to 0. So from here, this is 3, so a would be equal to minus 3. Okay, so when I put minus 3 instead of a here and 4 here, I will get 0. Okay, so 0 over 0. Now I can use L'Hopital rule. Okay, and then after that I will be able to find the value of b. So let's do that. So our limit now, it's like, it is limit as x approaches 4, it is square root of 2x plus 1 plus a, it's minus 3, it's minus 3 over square root of x minus 2. Okay, now I can apply L'Hopital rule. So I should take the derivative of the numerator and the denominator separately. So let's do that. So here this is constant, that's why its derivative is 0. So let's look at this one. So here we have square root of 2x plus 1, right? So how can I take its derivative? I can write this as 2x plus 1 to the power of 1 over 2, right? So its derivative, and this is equal to 1 over 2 times, I will put this 1 over 2 in front of this parenthesis, and then after that it is 2x plus 1, 1 over 2 minus 1, it is minus 1 over 2 times, and also the inside of the parenthesis, its derivative is equal to 2, okay? So these two cancel out each other, and from here we will have the 2x plus 1 to the power of minus 1 over 2. I can also write this as 1 over square root of 2x plus 1. Okay, so let's do this one. So this is square root of x. So square root of x, I can write this as x to the power of 1 over 2. So I will put this 1 over 2 in front of x. So it's 1 over 2 x to the power of minus 1 over 2, right? So this is also equal to square root of x. So from here we will get 1 over 2 square root of x. So let's write this here. So instead of this numerator we will write this one. So it is 1 over square root of 2x plus 1 over 1 over 2 square root of x. Okay, now we will put 4 instead of x here. So we will get 1 over 4 times 2, it's 8, 9, so it will be 1 over 3, and here this is equal to 1 over 3, and here when we put 4 instead of x, this is 2 times 2, it's 4, so it will be it will be 1 over 4. So when I divide it by when I divide this numerator by 1 over 4, it will be 4 times 4 over 1, which is equal to 4 over 3. So as you can see, this 4 over 3 is equal to our b. So b is equal to 4 over 3. Okay, so we know the value of a. So what was the question? It was asking a times b, so which is also equal to minus 3 times 4 over 3. So this is equal to minus 4. In this question we have the inflection point of the curve f of x is equal to x to the power of 3 plus 6x squared plus m is on the line of y is equal to x plus 3. So what is the value of m? So when we see this inflection point, we know that we should take its second derivative of our function, and then we will make it equal to 0. Okay, so let's do that. The first derivative of f of x is equal to 3x squared plus 12x, okay, and the second derivative of f of x is equal to 6x plus 12. So I will make this equal to 0, and from here x is equal to minus 2. So as you can see, this minus 2, this is an inflection point. Okay, so it said that it's also on the line of y is equal to x plus 3, right? So I can also use this equation. So when I put minus 2 instead of x here, y is equal to x plus 3. So I put minus 2 instead of x, and y is equal to minus 2 plus 3, it's equal to 1, right? So these minus 2 and 1, these are the points we have. So since these points on this curve, we can put these values on the equation, okay, the one we have here. So by doing that, we will be able to find the value of m. Okay, so we will put minus 2 instead of x and 1 instead of y. So let's do that. So here fx is equal to x cubed plus 6x squared plus m. Okay, so here f minus 2 is equal to, it is minus 2 to the power of 3, it is minus 8 plus, sorry, this is minus 2, yes, it's 24 plus m. This is all, this is equal to 1, right? So this is equal to 1. So from here it is, we have here 16, we have here 16 plus m, which is equal to 1, and from here m is equal to minus 15. In this question we have f of x is equal to x plus 1 times x squared plus 1 times x to the power of 4 times plus 1 times x to the power of 8 plus 1. So what is the value of the derivative of f of 2 plus the value of f of 2? So here, in these kind of questions, it's hard to multiply one by one, okay? So let's multiply and divide this expression by x minus 1, okay? So, and then let's see what happens. So when you multiply and divide by this expression by x minus 1, here we will get x minus 1 times x plus 1, it will be x minus 1 times x plus 1. This is equal to x squared minus 1, right? The difference of two squares. So this will be, when I multiply these two, I will get x squared minus 1. So after that, when I multiply this one by this one, x squared minus 1 times x squared plus 1, I will get x to the power of 4 minus 1, right? So when I when I multiply these two, I will get x to the power of 4 minus 1. And after that, when I multiply also these two, it's same logic. X to the power of 4 minus 1, x to the power of 4 plus 1. So I will get x to the power of 8 minus 1. Okay, when I multiply these two, x to the power of 8 minus 1. And the last, when I multiply these two, I will get x to the power of 16 minus 1, right? So our function f of x will become x to the power of 16 minus 1 over x minus 1, right? Don't forget this x minus 1, because in order not to affect the function, I should also divide this expression by the same expression here. Okay, so I multiply by x minus 1, and also I divide by x minus 1 here in the beginning. Okay, so our fx is equal to now x to the power of 16 minus 1 over x minus 1. Now let's go back to our question. So we should find the derivative of f of 2 and the value of f of 2. So let's first find the value of f of 2. So from here, when I put 2 instead of x, it will be equal to 2 to the power of 16 minus 1 over 2 minus 1 is equal to 1. So it's equal to 2 to the power of 16 minus 1. So let's look at its derivative. So the derivative of f of x is equal to, now we will apply the quotient rule here. So the derivative of first one, it is 16x to the power of 15 times the second one, the denominator, it's x minus 1 minus the derivative of the second one, it is 1 times the first one, the numerator, which is equal to x to the power of 16 minus 1 over, it is x minus 1 square. Okay, now I can put 2 instead of x here. So when I do that, I will get here, let's see, when I put 2 instead of x, this will be 1. Okay, so it's 16. I can write 2 over 4 instead of 16 here. So it's 2 over 4, 2 to the power of 4 times, instead of x I will put 2, so it's 2 to the power of 15 minus, here we have 2 to the power of 16 minus 1, sorry, it's minus times minus, it will be plus 1, over, here we have 2 minus 1, it is 1, 1 square, it's equal to 1. So let's see, when I take the parenthesis of 2 to the power of 16, here we would have, this is 2 to the power of 19, so it will be 8 minus, yes, it's 8 minus 1, and we also have here plus 1, okay, over 1, I don't need to write that one. So here we would have the derivative of f of 2 is equal to 7 times 2 to the power of 16 plus 1. So what was the question? The derivative of f of 2 plus f of 2. So let's do that. So we have here 7. So f of 2 is equal to this one, right? 2 to the power of 16 minus 1. So the derivative of f of 2 is equal to this one. It's plus 7 times 2 to the power of 16, and we have plus 1. So these will cancel out each other, and here we would have 2 to the power of 16 times 8, because we have 7 here and then 1 here, right? So this is 8. We can write this as 2 to the power of 3. So our answer would be 2 to the power of 19, right? Because 16 plus 3 is equal to 19. So our answer is 2 to the power of 19. Now let's look at our last question. Here we have, these equations are defined in the range of 0 and 1. What is the maximum area of the circle that is tangent to the parabola y is equal to x squared and the curve y is equal to the square root of x? So in this question, since this square root of x and x squared, they are the opposite of each other, I can draw this line here, okay, and this line should be equal to y is equal to x, okay, because these are opposite to each other, okay. So after that, when I draw the tangent lines of these two functions here, okay, here, their value of tangent, actually they are equal to each other. Why? Because they are parallel to each other. As you can see, this tangent line, this line, and this one, they are all parallel to each other, which means their slope also equal to each other. So here, as you can see, we have this line y is equal to x, and from here we know that the slope is equal to 1. Okay, so how we find the slope? By taking its derivative. So let's look at this one first. Y is equal to square root of x. So when I take its first derivative, it will be equal to 1 over 2 square root of x. Okay, and this is equal to 1. So from here, when I do cross multiplication, 2 square root of x is equal to 1. So square root of x is equal to 1 over 2, and x is equal to 1 over 4. So here, when I look the other one, y is equal to x squared, okay, so here I will take its first derivative, which is equal to 2x, okay, so I know that this value is equal to 1, so 2x is equal to 1, and x is equal to 1 over 2. Now let's put these values in their places. So we said that for this one, x is equal to 1 over 4, right? So here, x is 1 over 4. So when x is 1 over 4, y is equal to 1 over 2, right? Yes, it's 1 over 2. So it's 1 over 4 and 1 over 2. Okay, so let's look at this one. Here we find the value of x is equal to 1 over 2. So when I put 1 over 2 instead of x, it is equal to y is equal to 1 over 4, right? Yes. Now this is our this is the center of the circle, okay, and this one is the diameter, right? So how can I find the value of this diameter? I can use the difference, I can use the distance formula. Yes, I can use the distance formula because I know these 2 points, right? I know the value of x and y here and the x and y here, so I can use the distance formula and I will be able to find the diameter, and then after that I will able to find the radius, and then I can find the area. So let's do that. So what was the distance formula? It is equal to square root of x2 minus x1 square plus y2 minus y1 square, right? So from here we will get square root of 1 over 4 square plus 1 over 4 square. Okay, so this is equal to square root of 2 over is 16, and it will go out as 4. So it's square root of 2 over 4. So this is our diameter, okay? So when I divide this by 2, which is equal to square root of 2 over 8, this is our radius, okay? Now everything is much easier. I know the area formula, which is equal to PR square, right? So I know our radius. So this is all equal to P times, when I take its square, it is 2 over 64. This is also equal to P over 32. So this is the maximum area of this circle.